Leveraging Hadoop for scalable data lakes. A 2024 perspective in 2024. Big data is evolving. Data lakes are now the best for storing and analyzing vast, mixed data. This includes both structured and unstructured data. Hadoop is key to big data systems. It helps build scalable data lakes. This guide explores using Hadoop to create and manage scalable data lakes. It addresses the challenges and opportunities that come with it. The role of Hadoop in modern data lakes. Centralized repositories store data lakes. Organizations can store raw data until they need it for processing and analysis. Unlike traditional data warehouses, data lakes support many data types. They are ideal for today's diverse business datasets. Hadoop's distributed storage and processing make them ideal for data lakes. Hadoop's distributed file system, HDFS, enables scalable storage. It splits large datasets into smaller blocks. Then, it distributes them across a cluster of nodes. This not only improves storage efficiency but also enhances fault tolerance. Key components of a Hadoop-based data lake. HDFS, Hadoop Distributed File System, the core storage layer. It offers scalable, fault-tolerant storage for vast amounts of data. MapReduce, the engine that enables distributed data processing across the Hadoop cluster. It allows for efficient analysis of large datasets. Yarn, yet another resource negotiator. It is the resource manager. It schedules jobs and allocates resources in the Hadoop cluster. Challenges in managing Hadoop-based data lakes. Hadoop's ecosystem is vast and complex. It has many components that need configuration and management. This can make it hard for organizations to set up and maintain a Hadoop-based data lake. Cost. Hadoop is open source, but setting up and maintaining a Hadoop cluster can be costly. This is especially true for hardware, storage, and skilled staff. Also, frequent scaling as data grows can raise costs. Future trends in Hadoop and data lakes. Integration with cloud platforms. Many organizations are adopting hybrid cloud strategies. They want to combine on-premises Hadoop clusters with cloud-based storage and processing solutions. Data lakehouse architecture. A data lakehouse merges the best of lakes and warehouses. The idea is gaining traction. Hadoop's flexibility makes it a good choice for data lakehouses. Conclusion. In conclusion, Hadoop is a powerful tool for building scalable data lakes. It copes with organizational data output in 2024 with seamless adaptability. Organizations can gain a competitive edge by using data lakes. As big data evolves, Hadoop's role will likely expand. It will support new data architectures, like data lakehouses and AI analytics. This will make it essential for businesses wanting to stay ahead.